All right, so this is chapter 6. I've already released assignments that this chapter requires or that depend on this chapter, and we learned a bunch of cool stuff about tables. We had some fun stuff. We learned about formatters, all those .where things, where the values of this column label r dot equal to r dot above or equal to some value. And there's also nots, not underscore equal to, not above or equal to, blah, blah, blah. We practiced with Pokemon, and I just want to practice some more with other stuff. So let me open up my Jupyter, and I highly encourage you to open up yours. I'm going to ask you to play around a little bit with some other fun data sets that I'll explain. So today is just going to be playing around, practicing all this stuff. So get on those Python reference pages, pick your favorite. I like both. It's like all this table stuff. Let's remember it. Let's practice it. And let me open this. I've got a fun data set to start with. So if you want, it's like they're all here, right, in this little temporary link. If you didn't already download all our data sets on your own computer, you can also do that. It's in our code from class. That whole data folder is available for you. Loading, loading, loading. But yeah, I've just got some fun data sets. I've got a serial data set. That's the one we're about to use. And it was published, from what I can tell, it was published in 1993. But I think the data for these serials in the serial data set was collected in like 1989. And so there's going to be a bunch of serials like maybe we've heard of, but others that we have not heard of. It'll be very interesting and fun. And we're going to analyze cereals because I love cereal. Honey Bunches of Oats is my favorite cereal, and it's sadly not in the data set. So, yeah. So good. So good. I don't know when they came out with Honey Bunches of Oats. We'll give them a shadow. We'll give them the benefit of the doubt and say that it didn't exist in 1989 or whenever they collected this data. But yeah, let's read that data set in and go from there for the day. Question first?
Can you remind us how to get to the thing with all like the table where it shows all the .wheres and stuff?
Oh, sure. I think both of these reference pages.
Thank you.
Both of these reference pages on our Jupyter Lab page. Yeah. That's what you're asking for, right? Yeah. It's also probably somewhere in the book, but this is a faster way to get there. But yeah, let's read in the serial data set. Is this finally loaded? Okay, good. I want to load... Oh, this is chapter 4. What happened here? There we go. We remember always to include data science from data science import star, or just like run that first cell in the sample file, and then I can do other things while that is ready. And so we had some fun with ice cream cones and Pokemon last time. I'll have a little dividing line for us for today. And I want to read in the serial data set. And so that is in my data folder /serial.csv. And so if you're following along in that temporary page, you do exactly the same. But wherever you have it, read it in, please. So table.read table, it's data /serial.csv. And I'll just call that serial. And there's only 77 serials that they kept track of back then. But let's see like the first 15. So you got some that we've seen before, like Apple Jacks, Cocoa Puffs, Cinnamon Toast Crunch, Cheerios all existed back then. But some of these other ones, like maybe I've never heard of them, maybe they went out of business, maybe they rebranded. So this is all that we have for our serial data set, and let's talk about the columns. So here are the column information. Here is the column information. Name, of course, is name of cereal. Manufacturer is a code for which manufacturer. Some of them probably have gone out of business since they made this data set, but like General Mills and Kellogg's and Nabisco still exist. Post still exists. Cool. I thought Purina was a cat food company, but maybe they used to make cereal. The type of cereal is either cold or hot. Most of them are going to be cold, but C for cold, H for hot. Number of calories and like all of these are going to be in terms of serving sizes. So calories is in calories per serving, not like the entire box's worth of calories. Protein is grams of protein. Fat is grams of fat in like a serving size of the cereal. Sodium is in milligrams for a serving size. Fiber is in grams. Carbohydrates, also grams. Sugars is in grams. Potassium, like sodium, is in milligrams because I guess we don't need a lot of that as humans. And then vitamins is a little weird. Vitamins is always only 0 25 or 100, and that's a percentage. That's like a percentage daily value. We don't know which ones, but maybe it's just like the ones recommended by the FDA. The vitamins and minerals that are added in, like usually to children's cereals, you're going to add in and fortify it with some amount of the recommended daily value of like essential vitamins. And then shelf is a fun one. I have some fun things to do with that if you don't ask the same question yourself. Shelf is what shelf the cereal was on at the store where they took this data. All right, and it's going in order from the bottom of the place. So here's my best diagram of the shelves. This is like this. The shelf 1 was the closest to the floor. Shelf 2 was the next one up, and then shelf 3 was the highest shelf in the aisle where they put their cereal at this supermarket. And weight is weight in ounces for a serving. Cups is number of cups in a serving. It doesn't have to be a whole number. It's like a third of a cup for bran, because bran is very fibrous and makes you feel full with only a little bit. And then rating, I cannot figure out what rating means. I'll have to go back to the original study. But this rating could be like a rating of how healthy the cereal is. That's one idea that some of me and my students from previous semesters were thinking. It could also be like a rating of like people who were like, I like the cereal. It could either be people's preference rating or like a rating that's combining some of these ideas, like not too much sugar, like it's like a health rating potentially. And so maybe we can analyze this one day when we have more knowledge, but I don't actually know what this rating is. We'll have to look it up. But yeah, that's the cereal data set. And what I'd like you to do is please follow my lead and read this into a table if you haven't already. I'll call it mine. I called mine cereal. Call yours whatever you want. And my question for you, friends, is to come up, just like last time. We're going to play this game a lot. Come up with 2 good questions as a group. Everybody sit next to each other. Please say hello and go to that written ice page again. I'll clear it out after you've done attendance. Go there, please.
Are you missing someone?
We lost somebody. I know. Yeah. So, yeah, please add your ideas, add your thoughts. 2 good questions, at least. Come up with them with the people sitting next to you. Also say hello and talk about your weekend for a little bit. But yeah, we'll pick some of your ideas. We'll ask those same questions together and try to answer them. So yeah, come up with some good ideas, good thoughts about the cereal data set. And here, by the way, is in small form a description of all the columns if we need that.
How the hell does something happen? Look at the test. It takes it from.
Is there a negative, really?
For all it just it's not bad for you. Don't lie.
I think that's probably their equivalent of we didn't have an answer, like we forgot to look.
Oh.
It's like they're not a number, maybe. Maybe we have to exclude that.
Yeah, like I guess the most common per serving. Oh yeah, it's different servings. It has cups. Yeah, it's those servings. So it would be. Yeah, but like it would be cup divided by calories.
What do we think?
We could. Yeah. Yeah, most calories.
Right, this too.
The rating is
It was rated for something. Rated rated R, something like that.
Is it for FDA guidelines? Is it current ones or
This was taken in 19 something. I don't think this is correct.
It'd be interesting to just have the price on them.
That would be.
Honestly,
They're not enough.
14 grams of fiber is insane. Over half your daily.
Show me. Show me.
Whole grain of extra fiber has 14 grams of fiber. Women need 25 a day on average. Does this still exist?
Look it up. Oh my goodness.
Oh, it only has high fiber, which is only 12 grams according to Google AI, which I'm sure is very.
Oh,
12
shit,
grams
so
per
accurate.
1 cup.
Hmm.
It's half a cup.
Half a cup and there's that much fiber in it?
Yes. 14 grams of half a cup.
That's absurd. Or is it just, is all of the data like per serving?
Yes,
Oh my goodness.
should be.
So, just a full cup is over your daily 5.
That's ridiculous.
I can eat this cereal.
Joe, you're gonna get so constipated.
Fiber is supposed to stop constipation.
If you have too much, it'll make it worse though.
Can I just replace like all fruits and vegetables with the all grain of extra fiber? 330 potassium, 25 vitamins, 0 grams of sugar.
Wait, we should find the cereal with the most sugar in it.
By serving.
Most sugar by serving, yeah.
Yeah. Okay. Can you just replace your diet with all bread with extra fiber? The chicken.
I don't know, man. I'm not sure if that's good for you. That's like 1980s GMOs right there. That's what the bodybuilders were eating.
50 calories for 14 grams of fiber.
You know, I'm like half a cup for breakfast, lunch, and dinner. That's more than you should be eating in a day.
It's 0 grams of sugar.
Exactly, that's all the bodybuilders were on. That's why they had like crazy bodybuilders back then. And that's what Arnold Schwarzenegger was
It
eating.
only has 4 grams of protein. Except for 50 calories, isn't it like 10 calories for 1 gram of protein is supposed to be the ideal?
I don't know.
So, really, you could 0 fat?
Exactly. See, this is what they were eating when they weren't bulking and they needed to cut. This is what they were eating.
It's 140 times sodium a lot.
So I'm sure it's better than what we eat now.
140.
Hold on.
Give you a couple more minutes. Yeah, I looked up the original source, and -1 just means they didn't have the answer there. And still, rating is just very vague. It's like a rating of the cereals. We have no clue what it really meant.
It's like vibes.
Okay.
Yeah.
So it's preferable that you don't eat more than 2.3 milligrams of sodium a day. So I think that's an insane amount of sodium. It says that the average adult eats 300 to 500, but most Americans have like 3.2 considering.
Okay, so this is the perfect diet. Like, except we'd have so little calories that
You just have like protein bowls. Like on one hand, you put all five of the brand, on the other you put muscle, and that's it.
okay, so you combine all grain with extra fiber and like the most high calorie milk you can find.
Yeah.
And it's the ideal diet.
Like it has to be the protein milk though. The protein powder because it has no protein.
It's 4 grams of protein.
4 grams. That's ridiculous.
I'm obsessed with this. Why did they stop?
This is probably horrible for you.
It's like the ultimate superfood.
That's like the stuff they were giving soldiers in World War II. That's like a hard fact.
All right, remember to press that submit button after you after you type up your ideas. I'll give you a few more seconds. But this will be fun.
I love the random group numbers.
Yeah, that's useful for certain classes. I used to teach a CSI 1 class here, and I would have students like submit or like click submit to get a group number, and then like I could separate odds and evens. Like you think this, you argue this way, you argue this way. That's why I added that.
Sure, at least one person made that there. Just fit that. Like super size, but
Hold on, what's the name of it again? Like all something.
all branded extra fiber.
All right, friends, let's take a look. Let's see what we're thinking. Let's look at some ideas. And yeah, thank you. Groups. Heaviest and lightest cereal. I like that idea. How could we do that? I guess it's weight times. I guess we don't know how numbers of servings though, do we? I guess like weight per serving, is that the question then?
It's in cups, so it's in the same standard of measurement.
Oh, we do have cups. Yeah, okay. So cups is number of cups in one, so it's like
It has like 1/3 of a cup, 1 cup.
so we can multiply weight in cups to get the end. Okay, yeah, let's do that. I like that. And then also I was looking at I think that like the people who made this maybe made some mistakes because where was it? Some of them have like ridiculous amounts of fiber, right? Some of these might be a little bit off. Let's show me this whole data set real quick. Where's the fiber column?
It's the one that has like a bunch of 200s in it.
200. Well, that's not the fiber column at least. That's the sodium column.
Right.
Okay. Never mind. I think yeah, I'm looking at a different version of the data set over here then. So yeah, let's ask that question. We want to know where were we? Heaviest and lightest cereal for each shelf. So okay, so to get that we have cups and then where did it go? Cups and weight. Weight per weight in ounces of one serving, and then cups is number of cups in one serving. So we have to figure out how many ounces are in a cup, and then we can do some multiplication. So cereal dot column, we can ask for the weight column, and we can ask for the cups column, right? Get the weight column, we can get the cups column, but weight is weight in ounces, cups is number of cups. So to make cups into ounces, does anybody know off the top of their head how many ounces is in a cup? I think it's, yeah, 8 sounds about right. 8. Okay, so 8 ounces per cup. So cups to ounces, if we do times 8, right? Let's kind of do this slowly. This is like ounces per serving, right? That's ounces per serving. And then we've got weight is weight in ounces of one serving. Yes. Number of cup. Wait, I still don't think we have the final answer, right? Because this is all still talking about one serving, isn't it? So we're talking about weight of a serving? I'm confused. What is the actual question? Is it weight of one serving or weight of like the whole box of cereal? Okay. I don't know if we have that number. Unfortunately, I was happy because like weight and cups, I thought that they matched, but I don't think they will give us that. I guess we can assume there's at least 10 servings. I don't know. I think that's a little bit harder, but At the very least, we can sort by weight. At the very least, we can sort by weight. So let's do that. Cereal.sort weight, and then ascending and descending should give us something cool to look at. So yeah, weight for the smallest ones. We've got puffed rice. Rice is very light. That makes a lot of sense to me. Puffed wheat. Wheat is just as light as rice, I guess. Shredded wheat. And everybody else is decently heavy. If you do not show, it'll show the whole thing. Why is 1 the only other answer? 1 ounce serving. Ooh, some of these are like large servings. Raisin Bran wants a lot of servings. A lot of weight of each serving. And so yeah, you could look at this, both ascending and descending, by saying like descending equals true. You're going to fill it in for me. Sometimes if you press tab, it'll fill it in for you. So descending equals true. These are the heaviest ones. I like that. Yeah. So let's do some other group ones. How many cereals have the name bran in it? And what is the average amount of fiber? I like that. So that's like a 2-step process. So we'll have to go and do one of those .where conditions to get which ones have the name bran in their name. So name, we'll do like where the name column values are containing bran. I like that. And then we can go and find the fiber of those ones. So let's do that. I like it. How many cereals have the name bran in it, and what is the average amount of fiber? So here's the entire cereal table. Let's get all the ones with bran in it. Is it always capital bran? It looks like it is. That's helpful for us. Cereal.where the name column values are containing capital bran. Here's every bran. There's apparently 13 brands. And what do I want to do with all these brands? I would like to find the average amount of fiber across all of them. So we can go to the fiber column. Well, column fiber. And then do a .mean. Yeah? Does that make sense? So on average, all the brands themselves have 5.73 grams of fiber, which is probably a lot more than every other, like all cereals total. So like every cereal containing, you can do not containing. So these are all the non-brands. Every non-brand does not have a lot of fiber on average. That's a fun question. I like that. Questions about how I solved it? Does that make enough sense? Is that how you would have done it? Or did I want to be over here? There's that one. Most calories per serving size by brand. Most sugar per serving. Okay, yeah, I like that. Most calories per serving size. So we do a sort of division. Calories per, I guess. Now the question is, should we do it by weight or by cups? By cups. All right, so let's divide calories per cup. That would make sense to me. So cereal, give me the column calories. Cereal, give me the column cups. Calories over cups. This gives me a bunch of numbers, like the amount of calories per cup of this cereal. And we could attach this per cup. We could attach this to the table again. We'd be like cereal. Let's select out just things that are interesting to us. Let's select out the name of the cereal. Let's do the calories, the cups, and then to that we can add a column with column. We can be like calories per cup, and we could put this thing that we just solved for right there. Let's try to make this visible. That'd be nice. That's for every cereal. I guess we could also do a sort on top of that, but does everybody see how I picked out the columns that I cared about, these 3, and then I attached a new one by calculating it. And then you could for sure sort by calories per cup. And if I don't want to type calories per cup again, you could also give indices of your columns, because this is index 0, 1, 2, 3. 0, 1, 2, 3. Okay. Sort 3, maybe, I don't know, descending equals true. So grape nuts, highest calorie per cup. If you're extra hungry, you don't have a lot of room, like maybe if you're going hiking or something, bring grape nuts. Makes sense to me. Cool. yeah, any questions about how I solved that one? You see, like the thought process, like get this value, and this is going to be one row, one answer. It's going to give a sequence of calories per cup for every cereal in order. Then I can attach that back into the cereals table by adding a new column with column, and then I can sort by that new thing, and we're off to the races. So that's fun. Where do I want to be next? Yeah, let's do group 8. One of yours. What shelf compared to rating? Yeah, so we're not really sure what rating is, but this would help us explore rating. So we could do maybe average rating of shelf 1, average rating of shelf 2, average rating of shelf 3. Does that sound right? Is that what you were thinking? Group 8? Well, let's try it. So we can pick out just certain shelves. So here's the entire cereal table. We can pick out shelf 1 by doing cereal.where the shelf values are equal to 1. This is all shelf 1 then. Shelf 1 only. And we can go and look at the rating for that. We can do column rating, which gives me every shelf 1 cereal's rating, right? If I do shift enter, there's every shelf 1 cereal's rating. And you can do like a dot mean or a dot average to get that quickly. That's the average rating, whatever rating is for shelf 1 cereals. For shelf 2 cereals, shelf 2 is not as high of a rating. Shelf 3 cereals, back to normal. So shelf 2 cereals, interestingly, have low ratings, whatever that means. Any questions about that? Because I have some questions as well, and I would like to try them for fun. So here are my questions. Have we heard the story of, like, maybe there's laws against this now, but back in the day for sure, like, the supermarkets would place things that would attract the attention of, like, a young child or a toddler at their eye level, like the sweet things, for example. And so I have a hunch that maybe they would put the most sugary cereals on the lowest shelves so that the kids, like, that's at their eye level, they see that, they see the pretty pictures and the colors, and they're like, I want that, please. They tell their parent that they're there with, hey man, please give this to me, I want it. I feel like that might be true, so let's discover if that's true, all right? So what we'll need to do then is to look at each shelf and see how sugary that shelf is as a whole. So we can do like average sugar content per shelf. Does that question make sense? And that will answer this question for us. Like, hey, did they put some sugary cereals on the lower shelves? We only got 3 shelves, so let's try shelf 1. So again, where shelf are equal to 1. Or how do I want to do this? Yeah, we can go even further than this. We can be like, yeah, let's break it down just for fun. We can do like shelf 1 equals this bit, right? This will give me all the shelf 1 cereals. We can call it something if we want to. And then we can say shelf 1 dot give me your sugars content dot column sugars dot mean or something. So that's the average sugar content in grams, I guess, per for all the cereals in total on shelf 1. And we can do the same for shelf 2 and for shelf 3. And if you want to do it fast, you just do it all in one line. So where the shelf is equal to 2, give me your sugars column and the average. Ooh, that's different. And then same for shelf 3. I see a shelf that sticks out to me, don't you? I see shelf 2, and that is apparently the middle shelf. It's the middle shelf. And so, like, I guess shelf 1, like, it's on the floor, kind of. Shelf 2, I feel like that's at the toddler's eye level, yeah? So I feel like they were doing some nefarious things here, nefarious business practices. They really were putting the sugary cereals on shelf 2, and we have proved that, right? That's so much bigger than all the others. Don't you agree? Questions about that one? So, yeah, even with a simple data set like this, you could discover cool things, or interesting things at the very least. So there's that one. My next idea is about hot cereals versus cold cereals. Like our hot cereals, usually like that's a, when I think of a hot cereal, I think of oatmeal. And so like there's no sugar in that unless you add it. So in theory, maybe hot cereals are healthier. We can discover that together and try to figure that out. So let's do, I don't know, let's make a little temporary table that will give us the ability to figure that out. Let's select out only the columns I need for that. I can do name for fun, and that's type is cold or hot, so I want the type. And then we have to define what it means to be healthy as well. So maybe we can define healthiness as like has a decent amount of like protein and fiber. Let's do that. You could also define it in terms of like what it doesn't have. You can also define it in terms of like, let's make sure it has low sugar or something. But let's do protein and fiber. And like this is a little simpler version of a table that we could then do math on. And so let's call this cold versus hot. And that's the data I want to look at. And so for this little bit smaller table, let's find the average amount of like protein in the hot cereals. So like let's ask this question first. What is the average amount of protein in the hot cereals? Cereals in the data set. And so that would be like take the table, go and find all the hot cereals, and that's where it's H. So it's C for cold, H for hot. So do where the type values are equal to, it's capital H. And so here's all the hot cereals. There are only 3 of them in the data set, so maybe this isn't a very good representative sample, but that's okay. We can get their protein column. Here's every protein value, grams of protein in a serving, and we can do the average. So 4 grams of protein on average for hot cereals. Then we do the same thing for the cold cereals. And it looks like they have a little bit less. That's interesting. All right. I like that. And we do the same for fiber. Put fiber down here. Average fiber for hot cereals. Average fiber for cold cereals. And so it looks like, interestingly enough, there is less protein on average in a cold cereal, but there is more fiber on average in a cold cereal, and I feel like it's the brands that are helping that move that number up, probably. So that's interesting to think about. Yeah, so this is just some fun questions to ask. Questions about how I solved that one and how I changed the ideas, because that's really what I'm trying to get at today. I want us to practice all that. Please play around yourself. Try to ask your own questions. What else? And then finally, my last question before I move on to a different data set is, we'll practice with another one. Does sugar correlate negatively with fiber? What I mean by that is correlating positively means like if one goes up, the other goes up. So sugar positively correlating with fiber would mean in a cereal, if there was more sugar, there's also more fiber. A negative correlation would be if the sugar goes up, does that mean the fiber goes down? Because I feel like those are 2 opposing ideas in a cereal. So let's see. And so, how do I want to do this? There's some different ways to like go and define this. So let's see. Sugar and fiber. We can kind of, what I really would like to do is give us a graph, and that might not be very easy for us. Sugars. I guess one thing that we could do. This is a harder question to ask right now without being able to make graphs. But we could just like select out like name for fun, sugars and fiber. And then we could sort by 1, I guess. We could sort by sugars and just kind of look at it. Let's show everything. And so here's sugar going up. Sometimes, and then the question is, does fiber go down? So here's sugar going up. Does fiber go down on average? It's kind of bouncing all around all over the place. Like, apparently, whatever this kind of raisin bran is, it has both a lot of sugar and a lot of fiber, which makes sense because of the grapes, right? The raisins are going to have a decent amount of sugar in them, but also there's fiber from the bran part. So raisin bran kind of throws this off. And so, like, that's something you'd notice. But I guess this one has the highest amount of fiber, which makes sense. No sugars, all fiber. And so, like, that's one way to answer it, maybe. But a better way to do this would be to make a graph. And we are not at that chapter yet. So, yeah, that's that question. Are we ready for a different data set to ask questions about? Yes? No, on a test, I'm going to let you access these 2 pages. So as long as you can find what you need from here, you're good. Other question? All right. So the next data set I want us to explore is there's a data set of like the passengers who were on the Titanic, which is fun. They got their names, they got like their ages and fun things. And let's import that and look at the columns. So I'll call it Titanic. Table, read table. It's just called titanic.csv. And look at them all. Got names and ages and whether or not they survived, unfortunately, because you know what happened. Here is that table, and here is what these mean. These column labels mean. P class means which class was their ticket in when these people bought their ticket for the Titanic. Like, were they a first class passenger? Were they a second class passenger? Third class was the cheapest ticket. Lower down in the ship as well. Survival. For us, it's called survived. Like they changed these around, but this is still pretty much the same. Survived is 0 they didn't, 1 they did. So they got on a lifeboat. Name is their name. Sometimes the name doesn't exist. Sex is male or female. Age is how old they were when they were on the Titanic. Some of these are nans, and so nan, remember, that's kind of like the -1 of the previous data set. Nan just means not a number. Some people do it like that with capitals. Just means not a number. We don't have data for that. We don't know. So we can get rid of those by finding all the values. If we want to find age values and do an average age or something, to get rid of nans, you could just be where the age values are above or equal to 0, and a nan would go away because a nan is going to fail every single comparison. SIB-SP means number of siblings or spouses on board the Titanic. So were they there with their wife or their husband or with their brother or sister? Parents, children aboard. Likewise, was a child there with their parent, or was this parent there with any of their children? And then ticket number is not very useful for us. It's just the number that was on their ticket stub. We can't really do much with that when we ask questions, I don't think. And then fare is how much they spent on their ticket in pounds. And so some of them spent a decent amount of money if you do the inflation calculation. Cabin is where they were. Some of these we don't know. Some of these have letters in them. So that's not very easy for us to work with right now with our current knowledge. And then embarked is where they got on the Titanic. And there are 3 options, C, Q, and S, for those 3 cities where you could have gotten on the Titanic. And that's the data set. Hopefully it's not too horrible to understand the different columns, right? But my question for you is, let's explore. So go look at that data. Try to answer some questions of your own, but also, yeah, so first of all, come into read it into a table, and maybe, let's see, maybe instead of coming up with 2 questions of your own, I've got some questions too. So yeah, I guess try it, I think. Come up with 2 questions as a group that you think you could answer about the Titanic passengers, and yeah, we'll take a look together. And you could, let's see, just in case, I don't know, it might be hard. So maybe refresh the written ice page so that I can clear it all out and then it doesn't get confused. Yeah, give this a try. Let me know if you're having any trouble reading into the Titanic page. But I've got some questions as well. I'll give you maybe some time to think about it and try to answer them to yourself first. Nice. Give you another minute to get some question ideas in there. And then I want you to try them too. Okay, that makes sense. Hmm. All right, that's my timer. And I just want to take a look at your thoughts and then see if you have any questions about how to answer them, because I want to give you a chance to try first this time. So yeah, I like this one. Great. What was the male to female ratio of people on the Titanic? Were there more males? Were there more females? You have to do some counts, right? So I think that's a fun thought. So I think my hint for that one is if you do a dot where on just give me all the males, give me all the females, you can then say dot num rows. That would give you a count of the male and the female passenger relationship. Okay? And then, yeah, the rest of these for group 10, average age and fare price. You just go to the column, get the averages, male to female passengers for each class. Nice, you have to do a dot where to get the classes separated, and then you can do another dot where on males and females. So that would be a couple of wheres in a row. I like that idea. And then, yeah, number of parents and children. You can do like a sum. You could, I guess you could divide like how many parents, how many children. I guess it might be hard to figure that out, or because what if you're a passenger and you brought like your 10 children with you, and therefore you would have 10 here, but your wife is also on board. Like if you're the husband, then your wife is also on board. I think that's going to show 10 for both of those people, and so you might overcount. I'm really not sure how to solve that.
Like in total.
Yeah.
Like in general, the ratio.
Mm-hmm. That makes sense. Yeah, I think you'd only get really like an approximation because of those issues.
I mean, what I'm seeing, it looks 1-to-1.
Oh, is it? Oh, good. In that case, yeah, try it out. Try it out first, and then we'll just take a look together. If you have any questions, but yeah, give them a try now. Give your questions a try. I can see that, yeah, siblings and spouses and parents and children. No, those don't add up together. Number of parents. Number of children. 'Cause, yeah, if you're there with your sibling, you've got a
Actually, wait, no, I think I may have counted wrong.
sibling. It might just be double counting. And if you divide by 2, maybe then that's okay. I can't decide.
Well, what I've done is I've separated one into like a child column
Mm.
and the other into an adult column.
Oh, so you've done the age. Okay, that makes a lot of sense. Yes, if you do the age, I think that would help a lot. And then if there's a number next to,
How do you get like the amount of rows in a table?
you can do just dot num rows, num underscore rows. So yeah, if you do everybody over 18 where they have where the par ch column has at least 1 in it, that means they're all parents. I like that idea. And then you could sum up their children per parent. But if it's a husband and a wife, I feel like you would still double count. If they both came together.
There was 64 children and 62 parents.
Okay.
So, not much insane happening. Unless it's like there's like 2 people that brought their 1 kid.
Yeah, I could see something like that still in my head.
Orphans George brought
Yeah.
like the other 60.
Exactly. But you could probably also condition on sib sp. Like, did you have, if you had a child, if you...
I only calculated based on parent-child.
Okay.
I separated into were they 18 and under,
Mhm.
or were they older than 18?
I like that
There
idea.
I took the numbers because that way
Mhm.
you're not like nullifying anything. It's just the ratio. How many people were logged as parents compared to how many people were children.
Okay, yeah, that makes sense. It's just based on age and not even looking at the par ch columns. Is that what you're saying?
I only used the parsonage column to filter out anybody that didn't have children.
I see. Okay.
And then I mean technically parsonage shows like how many you have, right? Because there's like 2, 5. So
Yeah.
I mean you could go further seeing how many children per parent if you wanted to do it.
There's got to be a way. Yeah, I still just feel like
That might be advanced for me. But
you'd have to do something special because I still feel like if the husband and the wife were there, you'd see like both of their, you'd see 5 twice.
you
if they
would
had
have to
children.
You would have to pair them by last name.
Yeah, something special like that. Exactly. Nice. Anybody else have questions or thoughts about how to answer your own questions? You finding cool ideas? Cool results?
The first time we had a table where it got rid of like the passenger ID price.
Mhm.
So now I'm trying to figure out how survive by class.
So you want to know just the you want to get just the survivors right now, or what? Where always needs something. Where survived, and then you say comma, are equal to 1. So don't close the parenthesis yet on after survived. It needs to be the are equal to 1 needs to be in there.
What?
Delete that closing parenthesis and put it there.
Thank you.
Yes. See some good ideas. Good answers there. Children with a parent.
Sorry, it's still not working.
Oh yeah, no worries. Yeah, keep asking questions until it does. Yeah, it's not very easy to understand. Our survive values are equal to 1. Doesn't. It's because you keep putting it back into itself there. I think you're changing the table that way. You should probably make a new one and then rerun this one. But actually, yes, that's okay because you use a request to Are you reading that one? There we go.
Awesome. Thank you.
Yeah, you're like putting an answer back into the variable, so like it was very confused. It wasn't a table in there. Number of parents per child. Yeah. All right, let me try at least one. I've got some other questions for us on the next slide, so there's plenty of time. But number of parents. I still want to tackle number of parents and children. I want to try that myself. I think that would be really fun. Let me think about that. Like, we know this person who was 2 years old had a parent on the Titanic. This person who was 20. Oh, that's even harder. We got a 27-year-old who brought their parents. So you can't even use age, right? Or unless they had children.
They probably have children.
Did they bring their parents? Like, or did they have children? Now is the question. You'd have to work with their last name, like you said. Darn. Oh, that's hard, but cool. But really cool. Yeah, that would take some thought. That would take some real thought there. Yeah, let's do at least one. Let's do yeah, let's do like one of these male to female rate things. Ratio of people. Let's break it down by class because that would be a couple questions. So I'll do group 10's question 2. I think that would be a good one to do. And then you let me know if you have any questions about how to solve the other ones. All right, we've got a table. It's called Titanic. I would like to separate everybody by classes. So Titanic.where P class values are equal to 1, 2, and 3 because it's 1, 2, and 3 there. What did I want to do? Where's my notes file? I think that would be fine. Where P class is, the P class values are equal to 1, that's class 1. And then we can get male to female ratio for each of those. So let's do like, I don't know, we can do percent female. How about that? So this is first class. Let's call it that. So this is the first class table. And then first class where the sex values are equal to female and then I can get a ratio by dividing that by like everybody in first class. So first class dot num rows. Does that make sense? Oh, did I do something wrong? Oh, sorry. This has got to be, yeah, this has got to be dot num rows. So just female num rows over everybody num rows. And so it looks like there's a little bit more men in first class. And then you can do the same for the other classes, second class and third class. Let's try to do it all in one line. So this is, let's do second class is where the P class is equal to 2. Oh no, because we have to do it this way. That would be hard. Yeah, never mind. You could do it on one line, but it'd just get too long. Second class. So this will be everybody in the second class. This is just the women in second class divided by everybody in second class. So it looks like, yeah, there's more men in second class too this time. So it's the female ratio. Male would be 100 minus this. And then third is where it's equal to 3. Divide all that. And so, okay, it looks like there are mostly men in third class. Well, mostly men in third class, which is very interesting. So more men in total for sure on the Titanic. Interestingly enough. So that's fun to think about. With that in mind, knowing now that there are more men than women on the Titanic, I have some pre-made questions for us to try. So work on yours if you haven't finished it, but if you finish and answered your own question, I want you to try these, and then I'll give us answers too. So try to get the survival ratios for men and women, because back in the 1800s, right, they were very like, let's save the women and children first, and that is almost certainly what happened on the Titanic. So can you prove that with the data? Can you see, like, we know that there were a lot more men on the Titanic, but what's the ratio of survivors? And you'll have to think about that question, because there's a couple different ways you could formulate it. All right. And then maybe break it up into ranges as well, like to pick out, like, okay, did they try to save the children first as well? Like, find everybody less than 18, get their survival rate, people between 18 and 30, like younger adults, older adults, which had the highest survival rate. I'm thinking maybe the children. And then finally, try to ask this question, see if you can formulate it properly. If you spent more money on your ticket price, and that's in the fare column, that's how much they spent on their ticket. If you spent more on your ticket, does it mean you survived? Do they try to save the rich people? There's also like side thoughts there, like the rich people were living on the higher floors of the ship, like they put the poor people closer to the engine room. That was harder for them to get out when it started flooding. So it's like a really sad story, but an interesting question to get. So give it a try. Let me know if I can. Then I'll be answering. A little morbid, but very fascinating. Well, that's today. Thanks. think that's gonna work. I'll give you another minute head start. All right, let me give these a try. So I think these are interesting questions. Let's do survival ratios for men and women. So it's the survived class plus the sex class, right? That's going to give us the answer. And so let's give it a try. We can ask, what was the ratio of men who survived by first picking out all the men, right? Titanic, where the sex values are equal to male lowercase. This will give me all the men. And by the way, if you're ever doing an R equal to, remember that that's the default. So you don't have to say that. You just say sex male. That defaults to R equal to. So here's all the men again on the Titanic. And then you've got survived is a 1 if they survived, and it's a 0 if they didn't survive. And an interesting fact arises because of that. It was a good idea for them to do 1s and 0s rather than like yeses and nos. Let me show you why. So here's the survived column for each of those. And so here's every man, 0 if they didn't survive the Titanic, 1 if they did survive the Titanic. I can get a rate really easily because what I want is total survivors over total people, right? Total survivors, not total survivors over total amount of men. Do you see how that would be like add up all the survivors, divide by the number of men? Do you see how that would be the average of all this? Because like the 0s and the 1s, you add them all up, divide by how many, that gives you the survival rate. Does that make sense? That's very useful. That's very cool. And so that's why they made them 1s and 0s. That was a useful reason to do it that way. So if I just say mean, it'll add them all up, divide by how many, and that is exactly the survival rate of men. Not too good, unfortunately. 18.9% survival rate. That's really sad. Yeah, so that's the idea. And kind of the way you get that, right, is you count how many survived, divide by the total amount. So that is, that's that answer. And just in case you don't trust me, you could ask this question in this way, be like sex, male, where they survived, where survived was 1. So that's this many, dot num rows. So that's number of survivors that were men, and then number of men total is just this. And so it was 109 over 577, which is exactly me doing this. Isn't that fun? That's pretty cool. And then female survival rate, same idea. Give me all the women, get their survived column, and give me the average. And so they definitely were trying to prioritize the women, which is good for that, right? So even though there were fewer women on the Titanic, like we've noticed, they tried really hard to save the women who were on board. Okay, so that's the first question. Are there any questions about how I asked it and how I found the answer? All right, let's next do the age range stuff. So survive ratios for like age ranges rather than male female. So let's do children, so under 18, and then like young adults and like older adults. Okay. So we can do, so here's the whole Titanic again. Let's get all of the children by asking the question, give me all of the people on the Titanic where the age values are, it's below, right? Below 18. Or another way to ask that would be below or equal to 17. Or you can also ask between or equal to, like from 0 to 17. You got a bunch of different ways to ask that question. And so here's all the children on the Titanic. And we could again ask the question, how many of these survived? What was the survival ratio among the children? So you column survived to get all the ones and zeros, and then get the average to get the survival rate of that class of people. And so it looks like over half of the children survived the Titanic. And so if we compare that to other age groups, maybe that will imply that they tried to save the children first, just like they tried to save the women. And so we can do the same thing for these other classes of people, like 18 to 30. Between or equal to is a good one for this one as well. Survival ratio for younger adults, much worse than the children. And then everybody above 30, that would just be or above. What was their survival rate? I mean, there's a lot of people in that category, and so it was a little bit bigger than the others. But if you split up more and more and more, I think you'd probably find similar values to this. But yeah, I think that is what I want to say. So the 3 different groups of people, you can see that the children were prioritized. And you can see that from the data, which is very interesting. Questions about that one? And then the last one is ticket prices. So like, if you spent more on your ticket, you're a rich person. Did they try to save you first as well? Let's see. So that was the fare column. So fare, we know the prices. If we do that, I don't know, not really a dot where, but we can just go and like, what was the average ticket price? We can look at that really quick. Like here's every fare. Some of them probably bought really expensive suites or whatever, but the average is 32-ish pounds. And honestly, that's probably, you can see that fares are pretty small for certain people, much larger for other, like this person spent a lot of money on their cabin, their room, okay? And so if we've learned about averages before, I'm sure that like this is being pushed upwards, almost certainly. So average is probably weighted too high because of like a couple people who spent an extravagant amount of money on their tickets. So maybe the median is a better answer here. We'll learn more about that eventually. But let's look at the ticket prices for the different passenger classes as well, just to prove that to ourselves, just as a side thought. So where P class values are equal to 3, or you can just put 3. So this is all the third class passengers, get their fare, get the average. So they paid a whole lot less, the third class passengers, and they were probably mostly third class passengers, second and then first class passengers. And so first class tickets were very expensive on average, but everybody else was underneath on average the total fare average price. So that's an interesting thought about averages in itself. Probably a graph would be nicer here. Like let's plot all the different prices for tickets. That's a possibility that we can do one day. But yeah, let's talk about survival things. So let's do like, because we could ask the question like, okay, the people who paid more than like the average fair price, maybe, did they survive? People who paid less than the average fair price, did they survive? And I think asking about like, okay, if people paid more than 32, did they survive? People paid less than 32 pounds on their ticket, did they survive? Probably is not the best question because of that reason. Because like it's just gonna pick out mostly first class passengers. Does that make sense? So I think maybe second class average price is probably a better one to like condition against. Like, okay, if the price was above this, did they survive? If it was below this, did they survive? I think that's maybe the better one to compare against. All right. So that's my thought. Dun, dun, dun. So let's see. Dun, dun, dun. Better than 30 at least. So that's my thought there. And yeah, so let's do that. So Titanic, where the fair price values are like above 20. People who paid a little bit more on their tickets. See, like here are the more expensive tickets, the fare was above 20 pounds. Get the survived column. And then get the average. And this was the survival rate for people who spent more than the average second class fare on their tickets. And you could say below or equal to, or you can just say like not underscore above. You can always get the opposite with not underscore. And this is people who spent less than $20 on, less than or equal to $20 on their ticket. Did they survive? What was their ratio? And it was quite a bit smaller. And so that does answer that question, doesn't it? It looks like a higher ticket price really did mean that you probably survived more often on the Titanic, which is crazy. There's a bunch of different factors at play there. It could have been like who was at which part of the ship. I think that the third, it's been a while since I watched the movie and I don't remember how accurate it is anyway, but like I think the third class was like deeper in the ship as well, and so it was harder to get out. Very sad. But that is an interesting question in itself. Okay. And so, yeah, I think that's most of what I wanted to say. Some other cool questions that come from that is like, what was the survival rate of, did we already do that? Like a first class, second class, and third class? Dun, dun, dun. No, we did male to female. So that's another thought. Like, all right, third class passengers, how often did you survive? Not too often. Second class passengers were more likely to survive. First class passengers, definitely the most likely to survive, interestingly enough. Yeah, so these are interesting thoughts. Like, all right, among the survivors, how much did they pay on their ticket? Or was it just a question of like, were you in the right place at the right time? Where survived is one. Like, sort by how much they paid. Somebody got in for free, apparently, but a lot of survivors, they didn't spend all that much on their ticket. They were third class passengers. And so they just happened to be in the right place, maybe. But on average, third class passengers didn't survive that often. So there's two sides to that coin, which is interesting. And then we could do the same descending. Like, what was the least expensive ticket of a survivor was free, or maybe like almost 7 pounds. What was the most expensive ticket of a survivor? Whoa, 512 pounds. Like, that's a ridiculous amount of money compared to the 7-ish from those passengers. Wow. So they were very, very rich, and they survived. Okay. I think that's what I want to do with Titanic. Any questions about that data set? So it's fun to ask questions, and we know how to make and find the answers now. And so for my last trick, the last thing I'll do before I give you time to work on things that are out, is I have one last data set about max and min temperatures in Fresno. I read all this off of Wikipedia last year. And so I think probably the rates are mostly the same, but it's this file. It's max min temperatures Fresno up to 2025. If you just start typing max and you hit tab, it'll fill it in for you. if you put this file somewhere for yourself, I'll call it temps. And then here is the table. And what I have in this table is a date. For every date of the year, I have the record temperatures for that date. So we have the highest high that's ever been recorded on a January 1st. And apparently it was 69 degrees Fahrenheit on January 1st. That was the hottest it's ever been, and that was in 1998. All right, and then the lowest low that's ever been on January 1st was 21 degrees Fahrenheit, so below freezing. And the year that that happened was 1976. And apparently 1976 was a very cold year. So those are those records, and that's how you read it in. And yeah, I just want you to explore, ask some questions. Here's how you read it in. That's the name of the file. But yeah, think of some questions, try to answer them. Encourage you to write them down. I'll clear this. So if you refresh the page one last time, you can enter in some new thoughts and please discuss and think of some good ones. But what are some questions about this Fresno max-min record temperature data that you maybe want to ask and answer? And then, so yeah, try writing down your questions, try to solve them and answer them as well. And then we'll come back and we'll try something. Questions you're trying to answer. Hmm. Hmm. Amazing. All right, I'll give you another minute of a head start, and then I'll try some of your questions. I also have some questions of my own. I also want to make a graph for us. I think that'll be pretty and fun. I'll show you that we can actually make a graph in a weird way with our current knowledge.
Questions. Questions.
One more question.
Let's do that.
All done. Yeah. Some more questions.
They are important questions. Let's try some of them. Oh, nice. You got one person with a thought. Thank you, Group 12. We love you. What month has the highest difference between record low and the record high? I like that. I like that a lot.
Definitely get the
Yeah.
range for January.
Nice, yeah. It was difficult. It was very difficult.
You need like a loop for that.
Mm-hmm. So let's,
Oh, no, loops in this class.
yes. Not in the, we're not going to use them as often as you would use in like a CSI 40 or kind of class, but we're definitely going to use them. Yeah. So yeah, that is a harder question, but we can at least do it for 1 month, like January. So record low and record high for a month. The way that you could find that is the way that you notice which month you're in is you can do, it's the date, and you're in January if it goes 01 slash. Does that make sense? So where the date values contain 01 slash, you have January dates. And you can't just say 01, by the way, because that would pull in like August 1st, because that would have like, there's an 08, 01, it would find the 01 from that one. So it's got to be 01, then the slash gives you January dates, right? So like January equals temps dot where the date value columns are containing if 01 slash gives us January. So this is all the January dates. Every January, 31 rows as we would expect. And then, yeah, we would like the difference between the record low and the record high. So that would be like January dot, let's get the max highest high and the min lowest low. So one way to get that would be highest high. So give me every highest high column. And then I can't remember. I know you can do a dot, you can do a max function, but I can't remember if there's a dot max. Let's see. Nice, there is. Cool. So that works too. Like give me that and then give me the lowest low. Yeah, you could do like a sort and get the first thing. Is that what you did? Yeah. Mm-hmm. That totally works too. So it looks like there's a 61-degree difference between the highest high and lowest low in January.
Is there a range function?
What do you mean by range?
Is the max temperature minus the minimum?
I wouldn't call that range, is the thing. Because like we do have a range. We learned about NP.A range, remember that?
No, range. R-A-N-G-E.
Yeah. We have an A range. But like that gives us a range of numbers within a space. But like this is, I guess I still don't know what you mean by range. Max minus min. No, there's just not a function that does that for us right now. Some libraries have that. I know in C++ there's a function that does that, but I can't remember if there's one in Python. Maybe NumPyland has something like that. Let's check. Like NumPy get min and max at the same time. What's the fastest way to do that? Yeah, sometimes there's like a .min max, which I think is what you want here. And no, it's just like everybody calls min and max separately in Python, apparently. Yeah. That's interesting. But one day we will learn how to make our own functions, and then you can make that one.
Sorry, I should be more excited about that.
Yeah, then you can make that one. And that's very exciting. Nice. Cool. Some of my questions are like, let's see if we can discover global warming. Let's see, so I call it temps. Let's get the highest high years and give me the average highest high year. So the dates, I think they started taking data probably in the late 1800s because Fresno was a city that is decently old in California. So that's the average year that the highest high was set, about 1970-ish. And then lowest low year, these are the years that they made the records for the lowest low for those dates. The lowest lows are a bit older records, and they're not being beat. Does that make sense? And so we're seeing that highest highs are occurring more recently than lowest lows, and that implies we're getting warmer. Okay, so there's that, and then we could see what's the lowest highest high year. So we can do a sort on highest high year. Descending equals true. Or I guess we can do it without descending first. So it looks like some of the highest highs were set in the late 1800s. That's pretty cool. So it used to be really hot, and it still is. But more of the records are definitely being set more recently. And we can see okay, yeah, 2024 is a very hot year for us. There's all those records, and I'll only have to update this eventually because I'm sure we probably broke at least one record this year. But there's that. We can ask the question of how many records were broken for highest high in the year 2000 or later. That's the kind of question we could ask. So give me the temps where the highest high year values are above or equal to 2000, set in the millennium or later. Here they all are. And let's see what else. That doesn't seem right. Oh, thank you. Yeah. Thank you very much. I was like, why does it give me back everything? Then you could ask num_rows. And so 133 of it's over a third, I guess, of the highest high records are from 2000 or later. Yeah, you can do other cool stuff like we did for January. What was the average lowest low for January? We did stuff like that. So just to spell that out, that was a question that I had. What was the average lowest low for January dates. And so here's every January date. Give me the lowest low because it's cold in January. And the average lowest low in January was 22 degrees, so below freezing, 10 degrees below freezing. Crazy. And so, yeah, these are fun questions. And there's plenty more where that came from, of course. What else do I want to do? Are we ready for a graph? I think so. Yeah, questions about anything before I show you something weird? I want to make a graph for us with our current knowledge. I claim that there's a way. It'll be text-based, but it'll still kind of look neat. This is something I will not test you on or anything. It's just a cool idea. So I'm going to need the NumPy library for this. So I'll import NumPy as NP. And then a cool feature of Python is you can have a string, str, and you can multiply a str by an int. And it will do that. It will just give you a string, like give you 32 highs. That will totally work. And so I think we could make a graph then by having like something that looks like a bar and then multiplying it by like the temperature. And like that could be a 1 day's bar in a graph. It would just have to be a vertical graph rather than a horizontal graph. But like that would work out, right? So let's make like a graph of, I don't know, all the highest highs in this kind of style. I think that will be possible, right? Because you got like 100, like 112 is a record, like that would like go off the page and then there's 2 lines. So we'll have to like scale this appropriately, but that's a good start at least. So let's do, what we'll do is let's take every highest high. Again, I won't test you on this, but it's just a fun thought. Here's every highest high. And like I want to make number sign bars for each of these so I can display it. But some of them, like 112, that's too large. And so instead of this, let's scale this by a factor of 3. So if I divide all these by 3 and then make this many number signs, it'll still be relative, but it'll still be like, then I can display it all on one line and won't wrap over. And so let's do this. When you multiply by a string by an int, you have to have an int. These are not ints, we have to round them. So np.round, all those things. And then for weird reasons, they still have decimal points, and so we have to make integers out of this, because you still cannot multiply unless you have an integer right there. These have a decimal place, and so they are floats. And so in the NumPy library, you can be like, as type int, which is not something I will test you on, but like that will turn it into integers, and then you can do the multiplication properly. So these are going to be the widths of our bars. We'll call that widths. Cool. It's a fun thought. And then all the bars will be multiply number sign into each of these. So bars. You still see that? Bars equals, and the way you do it is it's to multiply them all in. Sadly, you can't just like do it normally. If only you could say something like widths. Widths times like number sign or something. Unfortunately, it's not happy about that, and so there is a thing in NumPy as an np.char for characters .multiply number sign by all the widths. And so I've generated the widths, and then if I say that, that will multiply number sign by every width and give me a bunch of bars. There they all are, yay! They've been scaled so I can show them properly. And then we'll put this into a pretty place in a second. Well, those are the bars for every date. And this is just an array right now, and so it's trying to show it to me in like it's giving me 2 columns for fun. It's not something pretty just yet. But what we can do is we can attach, because this is an array with 1 string for every day of the year for as many rows as there are in the original table, so I can attach this as a column. That's where I'm going with this. Scroll, 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 get me to the end. So my original temps table, let's select out the date and the highest high. And so I start with this table, and let's attach with column highest high graph or something. And those are the bars that we've generated. And then if I show the whole thing, that's kind of like a graph. It will be right justified, right? Yeah, it'll be right justified because that's just how the tables work. And so you look at it over that way, kind of think of it this way. But there is a bar graph, technically, for highest highs. We've turned the highest highs, after we scaled it appropriately, into bars of a bunch of number signs. Isn't that fun? Yeah. But technically, that is a graph. And you can see the relative size at a glance. I'm sure there's a way to zoom out and like make the font size 2 or something for a split second in the settings. That might look cool because like you can see it all at once maybe. But this is good enough. Good enough for our purposes. Do you kind of understand what I did? Any questions about this? Again, I won't test you on it, but it's just a fun thought. We can technically make a graph right now if we try really hard. Cool. Okay. Yeah. And I think that was the last thing I wanted to show us. Are there any last questions about tables? We're now professionals. All right. And yeah, I think that's all I've got for us. That's what I want to do. I just wanted to practice and go over some stuff and remember all those different functions and operations. Hopefully we're feeling more comfortable about figuring out what we want to do by looking at these documentation files. That is a key thing. And yeah, if we're good, that is all that I've got for us. You've already got the assignments that depend on this chapter out. And so no new ones today. The rest of the time is all yours to work and ask lots of questions. And we will learn how to make real graphs next time.